All right, so when there's a number in front of the x squared, we said there was two ways to approach this. The one is trial and error, and the second is first times last. We could do one of each maybe. We'll do the first one, we'll do first times last. So I would do 6 times 3, and that's 18. And then I'm looking for the factors of 18 that would sum to positive 11. So I need them both to be positive. I have 1 and 18 and 2 and 9. That's the one that adds up to 11. I replace the middle term with the 2x and the 9x, and the order doesn't matter. After, there, Sophia just came back. And then we factor by grouping. So from the first set of parentheses, I can take out a 2x, and I get 3x plus 1. And the second set of parentheses, I can take out the 3, and I get 3x plus 1. So the 3x plus 1 comes out, and we group together the 2x plus 3. Questions on that method? So that's the first and last. The second is your trial and error. Honestly, because the last term is negative, so you're dealing with a positive 1 and a negative 6 and a negative 1 and a positive 6, I probably would have done first and last here, but let's just practice that trial and error. So for the first set of parentheses, I need to find factors of 4, which would be 1 and 4 and 2 and 2. And then I would want to reverse it too, so it would be 4 and 1 also. And I get x and then 4x. And then the second spot is going to come from the factors of negative 6. So you've got 1 and negative 6, negative 1 and 6, 2 and negative 3, negative 2 and 3. And then really you could reverse them all so that it would be negative 6 and 1, 6 and negative 1, negative 3 and 2, and 3 and negative 2. And then we want to try them one at a time. So if I did positive 1 and negative 6, and I do outer and inner, I get negative 6x plus 4x, which is not 23x. So I rule that one out. Then I go to the next one, which would be the same except opposite signs. So negative 1 and positive 6 just switches the signs. If the value is completely off, I would just skip each ones that are the same, just opposite signs, because it saves you some time. So then I would go to the next one, which is positive 2 and negative 3. And I get negative 3x plus 8x. That's 5x. That doesn't work. And I'd also skip the next one because it would only be a negative 5x. So the sign would only switch. Then I go to the next one, and it's negative 6 and positive 1. And I'd get 1 minus 24. Which is a negative 23. The value is right, the sign is wrong. So if we switch the signs, now I'd get my negative 1 and positive 24, and that's where the 23 comes from. Questions on either of those, either of the methods, and again, you get to choose. Questions from the homework from yesterday?
Homework was easy.
Good.
Yeah, I got 100 on the homework.
Great. Okay, so day 3, we're still factoring, but now they tend to call this factoring completely, and we talked about it yesterday, but how does this get harder? And it is because you start to have multiple steps to factoring. So the very first thing you're going to check for is, can you figure something out? So when I look at it, we're going to kind of put all the different kinds of factoring together. The very first thing I'm going to ask is, can I factor out something? And if I can, I'm going to factor out whatever that greatest common factor is. So we talked about it yesterday too, but like if they're all divisible by 2, or if there's an extra x on all of them, can I take that out? And that's the first thing you want to do. If what's left has 2 terms, so I would say that based on the number of terms, I would approach them differently. If it's 2 terms, look for the difference of 2 squares. If it's 3 terms and they are both the front and the first and the last are perfect squares, then I can look for a perfect square trinomial, which we'll go over in a second. So that would be 3 terms. If there's neither of those cases and there's 3 terms, then we fall back on what we did day before yesterday and today, where we find the factors of the last term that sum to the middle. Or if there's a number on the front, then we do the first times last or the trial and error. If there's 4 terms we factor by grouping, which is what we did on the second half of the first times last. So I would say the hardest part about these is knowing what to do as you're going through them because they're all going to get looped together. So those are some tricks. Look at 1, can I take something out? 2, how many terms are there? Are there perfect squares? Look for that kind of stuff to help you with it. All right, so if we look at the first one, is there something that can be factored out?
No.
No. Are there 2 terms?
Yes.
There are 3 terms there, right? If there's 3 terms, are they perfect squares?
No.
No, which means and there's nothing in front of the x squared, which means I fall back on find the factors of 6 that sum to -5. The last term is positive, which means they both have to be, and last one is positive. They have to have the same sign. Middle term determines that sign. So it would be -1 and -6 or -2 and -3, and that's the one that works. So this is your back to simple, basic factoring trinomials. We're going to keep going. Yeah.
So like
So they're all going to get mixed together is the trick.
when you can't factor it, like you should just do the one where you guess the numbers.
When it's not like a perfect square trinomial or something like that, yeah. Or there's nothing on the front. So like B, I can't take anything out, but there's a term on the front. They're not perfect squares. So this is my first times last. So 2 times -15 is -30. Factors of -30 that sum to 1.
6 and 5.
Good. 6 and -5. Good. Replace the middle term with them. And then factor by grouping and watch your signs here. That negative stays on the 5. From the first set of parentheses, I can take out a 2x. And I get x plus 3. Second set of parentheses, I need to change my signs. So I'm going to take out a -5. And I get x plus 3. And then I get x plus 3 and 2x minus 5. Nothing new so far, right? It's just that now they're not separated out by their sections. They're all going to be looped together.
So what's the difference between this one and the last one?
Nothing. It's just that they're all going to get mixed in together.
What do you mean by that?
Like you're going to get different 2 squares mixed in with those, mixed in with perfect square. They're all going to get mixed in together. So it's not like day 1, you only had one thing. Day 2, you only did one thing, right? There's a bunch of different kinds of factoring, and they're all going to be grouped together. All right, go to C. Can I factor something out?
2.
Yes, this time they're all divisible by 2. So I take a 2 out. This gets divided by 2. This gets divided by 2. And this gets divided by 2. And I get x squared plus 6x plus 9.
And now we factor.
And now we look. Are there factors of 9 that sum to 6?
Correct.
What are they?
3 and 3.
+3 and +3. So you will either see this written exactly like that, or that is actually a perfect square trinomial. It could also be written this. These mean the same thing.
Oh, so you don't go any further?
Nope. Now that is a perfect square trinomial, and we haven't done these yet this year. And there's a shortcut to factoring those, so we'll use this one, x squared plus 6x plus 9. The way I look for a perfect square trinomial to identify that it is so that I can use this shortcut is you look at the first and last terms. Are they both perfect squares? And they are this time. So then I square root the first term. This is the test to see if it's a perfect square trinomial. I square root the first term. I square root the last term. I multiply them together and then double it. And if that term, which is 6x, equals the middle term, then I know it's a perfect square trinomial. And to factor, oh, thank you. To factor the perfect square trinomial, you square root the first term, you square root the last term, you take the sign from the middle, you put it in parentheses, and you square it. So if I was to square root the first term here, I'd get x. Square root the last term here, I'd get 3. Take the sign from the middle term, put it in parentheses and square it. It's the same thing as factoring it the other way. I would say if there's nothing on the front, then it's probably not that big of a time saver, but the more complicated they get, the quicker that last step helps you with. So if the first and the last are perfect squares and there's 3 terms, then you want to start to look for that. We'll see it again. All right, we're on what? D. Okay, can I factor something out of this? No. Obviously it's not 2 terms. The first and the last are not perfect squares, so this falls back on my first times last. -3 times 10, or trial and error, which is -30. Factors of -30 that sum to +1. What are the factors of 30 that are 1 apart?
6 and 5.
5 and 6, and I want the bigger one to be positive, so -5 and +6. Then I replace the middle term with those. And I factor by grouping. From the first set of parentheses, what can you take out? You could take out an x, or you could have taken out a -x. You could do either one. But whatever you do there obviously affects what's left. So this would be -3x minus 5. So then I need to change the signs on the 6x and the 10. So I'm going to make it a -2. And I get -3x minus 5. And then I get -3x minus 5 and x minus 2.
How did you just take out a -2 out of nowhere?
What do you mean out of nowhere?
There's no it's just 6x plus 10.
Right, they're both divisible by 2. But I also needed to change their signs so that they match these signs. Yeah.
For the first one, parentheses, can you just take out a -x?
Yep, so if you took out a -x from the first one, then you don't have to take the negative out of the other one. So it would be 3x plus 5, and then I'd only have to take out a 2. 3x plus 5. So I get 3x plus 5 and -x minus 2, or plus 2. So both of those are right.
All right.
Questions on that one? Way on? E. All right. Can I factor something out of this? What goes into both 3x squared and 48? 3. Take out the 3. X squared minus 16.
Perfect square.
Difference of 2 squares, right? They're both perfect squares. There's a minus between. So how do I factor that?
You just go like 3 parentheses.
Good. Square root the first term, square root the second term. One gets a plus and one gets a minus. It's the difference of 2 squares. When they're both perfect squares with a minus between, you square root each. One gets a plus and one gets a minus. Now go to the next one. What can I factor off of these?
4.
4 comes out. X squared, this divided by 4 is? 4 goes into 14 how many times? 3 times. 4 goes into 24? 6. And then there's a minus between them. Can I factor that further? Difference 2 squares again. Square root, square root,
X plus
square root, square root. One gets a plus. Good. One gets a minus. Next up, we're on G. What do I do first?
factor 3 out.
Take out a 3. So I'm dividing each of them by 3, which leaves x squared plus 7x plus 6. Now we're back to a trinomial. There's nothing on the front. So can I find factors of 6 that sum to 7? 6 and 1. Or 1 and 6. Order doesn't matter.
That was pretty easy.
Still good? Okay. H, what can you do first? Mars.
Take out a 5.
Take out a 5. And I get 2x squared minus 5x plus 3. Back to 3 terms. They're not perfect squares, so this goes first times last or trial and error. So 2 times 3 is 6. Factors of 6 that sum to negative 5. So they have to be negative. Negative 1, negative 6, negative 2, negative 3. That's the one that sums to negative 5. So I'm going to replace the middle term, but don't forget that that 5 is on the front. So 2x squared minus 2x minus 3x plus 3. And then when I factor by grouping, watch your signs because that negative is on the 3. From the first set of parentheses inside, I can take out a 2x and I get x minus 1. Second set of parentheses, I could take out a 3. If I make it positive, it's not going to change my sign, so I want to make it a negative 3. And I get x minus 1. And then what's inside the parentheses becomes one factor, and what's left over gets grouped together. And there's factored completely. So by completely means all the way, obviously. If you had the time to check, you could FOIL that back out, and you could check. I would FOIL the second and the third, like those 2 parentheses, I would FOIL those out, and then I would multiply by 5 at the end. Questions on those? All right. Go to the next one. Can you factor something out? No.
No.
So what are we going to do?
So multiply.
First comes last. I'm looking for factors of negative 30 that sum to positive 13. So bigger number has to be positive and they have to be different signs. 1, negative 30. 2, negative 15. Or sorry, bigger one has to be positive. I just said it and wrote with different. Negative 1 and 30. Negative 2 and 15. And that's the one that gives me 13. Replace your middle term. And factor by grouping. What can you take out of the first set of parentheses? Five x squared and 2x. Both have what? X. Take out the x. And I get 5x minus 2. 15x and 6. I can take out a what? 3. Good. God bless you. And then I get 5x minus 2 and x plus 3. And again, if I wanted to check it, I could just FOIL those back out.
We have.
All right, so this one, I'm going to multiply first times last. I get 33. Factors of 33 that sum to 34 would be 1 and 33. Replace the middle term and factor by grouping. So I'd get x and 3x plus 1. And I'd get 11 and 3x plus 1. So I get 3x plus 1 and x plus 11. Thank you. Questions on that one? All right, the second to last one, how do you start it?
You divide 2 by 2.
Take out the 2, and I get x squared minus 10x plus 25. So if you catch it, it's a perfect square trinomial. 5 times x would give you, and double it, and it's 10x, so it works. You can use the shortcut to factor it, which is square root the first, Square root the last, take the sign from middle, put it in parentheses and square it. If you don't catch it, you can find the factors of 25 that sum to negative 10, which would be negative 5 and negative 5. Both of those are right. Correct. The last one, can't factor anything out. Multiply negative 5 times negative 6. You get positive 30. Factors of positive 30 that sum to negative 31, negative 1 and negative 30. Replace your middle term. And then factor by grouping. Take out the x. I get negative 5x minus 1. Take out a 6. Negative 5x minus 1. And I get negative 5x minus 1 times x plus 6. You could have also taken out from here, you could have taken out a negative x, and it would have been 5x plus 1. And taken out a negative 6, and it would have been 5x plus 1. And then I'd get 5x plus 1 and negative x minus 6. Both of those are right. Questions? All right, we're going to do a booklet, but you are going to see questions that start off with the 4 terms like factoring by grouping. So we've been factoring by grouping like in our process, but let's just say it said 5x squared minus x plus 30x minus 6, and it said to factor by grouping. So it starts this way. I would group the first 2 and the second 2. I would take out the x. I'd get 5x minus 1. I'd take out the 6. I'd get 5x minus 1. And I get 5x minus 1 and x plus 6. So factoring by grouping is the only time there's 4 terms, other than if it was just like greatest common factor. It's the only time there's 4 terms. So pick them in pairs. But you'll also see it where they're like opposites. So let's say it said 5x squared minus x. And then negative 30x plus 6. And when I group this, I take out the x, I get 5x minus 1. If I take out a negative 6, I get 5x minus, no, sorry, it's not that one. It's this one. It would be 6x minus 30. So when you take out the 6x, it becomes 5. Hang on. Trying to make this up on the top of my head was not a good plan. 1 minus 5x. So let's say it said this. So this would have been a plus, and this would have been a minus. Okay. Let's say after you factor it, you end up with this, where these are not the exact same things, but they are opposites. So if that happens, then you actually can take the first one, so take whatever this one is, and use that as the greatest common factor. Leave the x, the one next to the one that was the first one, but change the sign on the 6. Which would be what would happen if I, in fact, change that sign, it would reverse it. So instead of having to go through that whole process where I have to reverse the order, if what's inside the parentheses, so let's just say it said x and it said x minus 3, and then it said plus 4 and it said 3 minus x. If what's inside these parentheses are the opposites of each other, so same terms but opposite signs, then I would grab the first parentheses, I would keep the x, and I would change the sign on the positive 4 to be negative 4. And it will correct that opposite sign. So that's an option. Okay. I don't know if it comes up. I can't remember if it comes up in the booklet, but just in case it does. God bless you.